Okay, so good evening, friends. So, welcome to the problem solving session for the NPTEL online course on wastewater treatment and recycling. I am Akash Saha, teaching assistant for this course, and I am a PMRF scholar at IIT Madras, pursuing my PhD in environmental engineering. So, we are into week 8 now. So, let's have a quick recap regarding the week 8 contents. So, we started with the introduction to sludge management, like what are the various sources of sludges in wastewater treatment plants, the different kinds of sludge, starting from the primary and the waste activated sludge, and the different stages of sludges in wastewater treatment system. And then uh, your volume is low. Okay. Is Can you increase your volume at the system also, if possible? I think from my end it is clear. Okay. Okay, so then we moved on to the quantity and the characteristics of the sludge, like the chemical composition and the challenges related to sludge management. And then we looked into various sludge processing and treatment techniques, starting from the sludge thickening, sludge stabilization and conditioning, and then dewatering, hygienization, and disposal. So this was all the content related to the sludge management in week 8. So now we will solve some problems. We'll start with some subjective problems and then we will discuss the multiple choice type of questions. Okay. So let's see. So this is the first subjective numerical which I have for practice. So it says that determine the liquid volume before and after digestion and dewatering and the percentage reduction for 500 kg, which is dry basis, of primary sludge with the following characteristics. So we have been given 500 kg of primary sludge, uh, and then after digestion and dewatering, some part of it will there will be reduction in the volume. So we have to find out everything, and all the characteristics are being given for the primary and the digested sludge, starting from the solid percentage, the volatile matter percentage, and the specific gravity of both fixed and volatile solids. So we will see how to solve this problem. First, try to go through the problem once again and see if you have any doubts. You can ask me right now, and you can note down the parameters. We will solve the problem. Just I will keep it for 10 or 15 more seconds, then we can want to solve it. Okay, so I hope you have noted the question or taken a screenshot. We will see how to solve this. So this is the question number 1. So we have been given all the parameters. So first we will try to find out the average specific gravity of all solids in the primary sludge. So suppose the specific gravity of the solids present in my primary sludge is St. So I can write 1 by St will be equal to, now how much of fixed solids are present? So volatile percent is given as 80%. So my fixed solids will be 0.2 and the specific gravity of the fixed solid is 2.5 plus volatile part 0.8 and the specific gravity is 1. Okay, so with the help of this equation, I will be able to find out the specific gravity of the solid in the primary sludge. Okay, so this will give 1 by St equal to 0.88. Hence, I will get St as 1.14. This is for my primary solids. Okay, so now we will find out the specific gravity. I am writing the short form SPGR, specific gravity of primary sludge. So again, now we have to find the specific. First, we have found out the specific gravity of the solid. Now we will find out the specific gravity of the primary sludge. Okay, so again, suppose my specific gravity of the primary sludge is Sp. So I'm writing 1 by Sp. So what is the solid content? Solid content is how much? It is 5%. So 0.05 divided by the specific gravity, that is 1.14, plus the remaining 0.95 will be water. So it is by 1. So this will turn out to be 0.99. Hence, the specific gravity of my primary sludge will be 1.01. Okay. So I hope you are able to differentiate between the specific gravity of the primary sludge so primary sludge and also the primary solids. Both are different things. So we have found out the specific gravity of both the things. So now to find out my volume of primary sludge. So after we know the specific gravity, we will be able to calculate the volume of the primary sludge. So my volume of my primary sludge will be equal to, so total dry basis content is 500 kg. I will divide it by the density kg per meter cube, okay, into the specific gravity into the solid content, that is 0.05. So in that way, I will be able to find out the volume of my primary sludge, and this will come as 9.9 meter cube. So we have completed the first stage of the question where we have find out the volume of the primary sludge in the system. Okay, so now this primary sludge will go through dewatering and digestion, and then the parameters will change again. So again, we have to find out the new specific gravity of the digested and dewatered sludge. Okay, so this was all about the primary sludge. Now we will see how to solve for the same again. So first we have to find out what is the volatile matter percentage after my degradation. So my volatile matter percentage, it will be equal to the total volatile solids after digestion divided by total solids after digestion, okay, into 100. So this will be roughly equal to my volatile solids in the primary into the mass of solids into 1 minus VSR. What is my volatile solids ratio? Divided by the total solids will be my total mass minus mass of the solids, that is ms into zero point 0.8 into, or I will not, wait, just a minute, or I should just write ms into my volatile solids of primary into the how much volatile solids ratio into 100. So my volatile solids in the primary was 0.8, then it is 500 minus 500 into 1 minus 0.6 divided by 500 minus 500 into 0.8 by 0.6 into 100. So in the question it was given that 60% destroyed. So that's why the 0.6 is coming into the picture. So my volatile matter percentage will be 61.5%. So once we know the volatile matter percentage, now we can solve rest of the problem. So now my average specific gravity of all solids in the digested sludge. First we saw about the primary sludge. Now we will see for the digested sludge. So suppose the specific gravity is SS is equal to, so how much? So this is the volatile solids content. So my fixed solids content will be point zero 0.385 divided by 2.5. This is the specific gravity of the fixed solid plus 0.615 0.615 by 1 equal to 0.679, or my SS will be equal to 1.3. This is my digested solids. Okay, so my specific gravity of digested solids, or sorry, digested solid we have found out. So it will be digested sludge. Okay, so suppose it is S digested sludge SDS. So zero point 0.2, again, what is the uh, solids content divided by 1.3 plus rest is water, so 0.8 by 1 is equal to 0.95. So my SDS will be again 1.05. So my volume of digested sludge VDS will be again, so out of the total some part will get digested, so volume will reduce. So 500 minus 500 into zero point 0.8 into zero point 0.6. So why 0.8? Point, because in digestion only volatile matter will get digested, not the fixed part. So 500 into zero point 0.8 considering the volatile matter, and out of that zero point 0.8 volatile matter, 60% is getting degraded, so zero point 0.6. So this is the idea behind this. So again, divide by density into the specific gravity into the solid content, so it will come as 1.2 kg meter cube. So we have seen that my earlier volume was 9.9. So from 9.9 meter cube, after digestion and dewatering, my volume is 1.2. So there is a huge change in my volume of the sludge. So we'll see the volume reduction percentage, because that is what's asked in the question. After digestion and dewatering, so it will be 9.9 minus 1.2 divided by 9.9 into 100 is equal to 87.8%. So this is the volume reduction. So we can see with the help of digestion and dewatering, we are able to minimize the sludge volume from up to 87.8% in this question. So this was the whole question. Do you have any doubt in any of the steps? I hope it is clear to you all. Can you please respond, anyone? Or if you have any doubt, you can ask me. I hope I am audible to you all. Is it fine? Should I go to the next question or you have any doubt? Hello. Saket, do you have any problem with this question? You saw this question from the start, right? Others have joined late, I think. Okay. So if you have joined late, there is nothing much. You can go through in my YouTube channel again, or I will just give a quick revision. So there is 500 kg of dry solids. So both the primary sludge constituents characteristics and the digested sludge characteristics are being given. So we have to just find out what is the volume percentage reduction in that sludge. So simply first we found out the average specific gravity of the solids, primary solids, then for the primary sludge, and then the volume of the primary sludge. Then the volatile percentage matter after digestion and dewatering. Then again for the digested sludge, we found out the specific gravity and then the volume of the digested sludge. And after, in the end, we found out the percentage volume reduction after digestion and dewatering. So this was the whole question. You can go through it once again in my YouTube, or then if you have still have any issues, you can ask me over mail or anything. Okay. So I will move to the next question now. So this was the answer which we got. Okay. So the next question is a design type of problem. So here we have to design some a gravity thickener rather. So it is a gravity thickener for both combined primary and waste activated sludge. So we have to take care of all the sludge, that is both the primary and the waste activated, and the characteristics are given. So in the characteristics we have the specific gravity, the solids percentage, and the flow rate. So it is given for both peak and average flow conditions. Okay. So we will see how to design a gravity thickener. It's a short exercise. So here some, again we have to make some calculations regarding the solid contents and all, and then based on the solid loading rate we have to fix up the dimensions of the gravity thickener. Okay, just go through the question once again and take a screenshot of this question. We will try to solve because these parameters are important and it will help us to design. So please take a screenshot of all the uh, characteristics. Okay, we'll,
Sir, are these questions are related to gate level questions?
sorry, I didn't get you.
Sir, are these questions are related to gate level examination?
Gate level examination means, see, in gate they won't ask you to design a gravity thickener, but they can ask any of the step of the design of gravity thickener. Okay, suppose in a gravity thickener design, first we have to find out the primary sludge or the dry sludge solid content. So that dry solid content question can be a question in gate, or they can ask you, they will give you the dry solid content and then ask you what will be my uh, reactor, what will be my reactor dimension. Suppose my solid loading rate is this much and this is the flow rate, so what will be my dimension of the system. So though not full question will be a gate question, but any part of this design problem can be a gate question. Okay, so
Okay, sir.
so if you know the full design, or if you know how to go about the design, you can solve any of the part and you can solve the problem. It can very well be a gate question.
Means these questions are lengthy and in gate short questions are asked.
Yeah, definitely. So in gate, because in design problems, there is no concrete answer, right? There is not a fixed answer. The answer can vary based on my design parameters or my design considerations. So they will give you fixed values and they will ask you any of the part. But in design problem, you have the liberty to just extend the parameters here and there and solve the problems. But it should be within a limit. So that is the difference. If so, that's why I kept the design problem so that you know all the steps, and if given the parameters, you can solve any of the other characteristics. Okay. So we'll see how
Okay,
to
sir.
solve this problem. So we will solve this for peak design consideration. Okay. So if peak design considerations are met, then our average conditions will be taken care of. So at peak design consideration. So first for primary sludge. So for my primary sludge, what is my kg per day dry solids? So how much dry solids I am getting? So it will be equal to the flow rate, that is 420 meter cube per day, into the specific gravity, okay, into 0.034, that is the solid content gram per gram, into the density. So this will give my dry solids of primary sludge per day in kg per day. So it will be 14780 kg per day. Similarly, for my waste activated sludge, I am writing it at WHS. So kg per day dry solids. So my flow rate again will be 2500 meter cube per day into 1.005, which is the specific gravity, into the solid content will be 0.0023 into density. So it will be equal to 5779 kg per day. So in that way we found out what is the my dry solid content, because in my gravity thickener I should know how much dry solids are coming per day. So my combined sludge mass will be equal to 14708 plus 5779, which is equal to 20487 kg per day. And my combined flow rate, so my combined flow rate will be equal to 2500 plus 420, 2920 meter cube per day. So this was the first part where we have found out what is my mass of dry solids per day in the case of both primary sludge and in the case of my waste activated sludge, and then we have find out the combined weight and the combined flow rate. Okay, so now next part will be we have to find out what is the percentage solids in my combined sludge, because when my primary sludge and the waste activated sludge is getting combined, so what is the new percentage solids? So here we have to first assuming the specific gravity of my my combined sludge to be 1.02. So this is my assumptions. So my percentage solids will be equal to my total weight kg per day divided by the flow rate meter cube per day into 1.02 into, again the same formula we are applying, we are finding the solid content here. So this will be equal to 0.69 percentage. So why we have found out the percentage solids? Because based on my percentage solids content, we will decide how much solid loading rate we have to give in the gravity thickener. So this percentage solids will govern my solid loading rate. So as the sludge concentration is between, so it is 0.69, so it is between zero point 0.5 to 1.5. So whenever this is the case, my solids loading rate, I can take it as 50 kg per meter square day. 50 kg per meter square day. So this solids loading rate is important to find the surface area of my gravity thickener. Okay, so based on my percentage solids, this percentage solids of my sludge is the amount of the solid content. So as my solid content is between zero point 0.5 to 1.5, so for different ratios, we have different solid rates. So for 0.5 to 1.5 percentage, it is around 50 kg per meter square day. Okay, so now my area, what will be my area? Area will be again the the total solid content, that is 2487 kg per day divided by solid loading rate, kg, so per day. So my kg and day will get cancelled. I will only get the meter square. So it will be around 409.7 meter square. Okay. So to find out the surface area of my gravity thickener, we just divided the total solid in a day divided by the solid loading rate, like how much per day will be applied per meter square. And also my hydraulic loading based on my flow rate. So my hydraulic loading based on my flow rate will be 2920 meter cube per day divided by 409.7 meter square. So my hydraulic loading will be 7.13 meter cube per meter square day. Okay, so we know the hydraulic loading will be 7.31. So at last, once we know the area, we can find out the diameter, because most of these uh, gravity thickeners are in circular cross section. So my diameter of the thickener will be d equal to root over 4 into the area, that is 409.7 divided by 2 pi. So it will be around 16.15. So in that way, we found out the diameter, we found out the hydraulic loading, we found the area and the solid loading rate. So these were all the design parameters that we should know for my design of a gravity thickener based on the parameters that we have got. So it's pretty simple. I will just go through it once again. First, we found out what is my dry solid content per day in the primary sludge, and then the dry solid content in the waste activated sludge. Then we found out the total sludge mass and the total flow rate. Okay, so once we got all these parameters, then we found out what is my percentage solids, assuming a specific gravity of my sludge. So we found out it to be 0.69 percentage, and based on that, we found out the solid loading rate as per the guidelines. And then we found out the area, hydraulic loading, and the diameter of the thickener. So suppose in gate they are focusing on the diameter of the thickener. So they will give you the solid loading rate. You may have to calculate the uh, dry solid content and then divide with the solid loading rate, find out the diameter accordingly with the help of the area. So in that way they can ask. So the answer would be much specific. Here, if I choose my solid loading rate at 60, suppose in the case of 50, I change it at 60. I want to increase it. So my area will get decreased, my diameter will get decreased. So in design, I can tweak with the values. Whereas in the case of any gate question or any particular question, there will be specific values which will be given to you. Okay. So I hope it is clear to all of you regarding the design of this gravity thickener. We will move on to the next question now. So this is the question. So from the following analysis of untreated and digested biosolids, determine the total volatile solids reduction achieved during the digestion. So we have some untreated solids which is going through digestion, and then we are getting the digested biosolids. So the volatile and the fixed solid percentages are given for both the types of sludge, that is the untreated sludge and the digested sludge. So we have to find out what is the total volatile solids reduction in this case. So we have to assume a few things. We have to assume that the weight of the fixed solids is equal in both the cases. Like before digestion and after digestion, the fixed solids are not changing. This is the first assumption. And the second assumption is the volatile solids are the only constituents which are lost during digestion. So the fixed solids are remaining intact, they are not changing, whereas the only change happening is to the volatile solids. So these are the two major assumptions in the question, which is normally the case. So we have to find out the total volatile solids fraction. Okay.
Assumption type questions may also be asked.
Sorry, I didn't get you.
So, assumption type questions.
No,
Uh,
assumption type questions means it can be asked for any other concept, but here I have just mentioned the assumptions. Like whenever we are considering digestion of solids, we consider that only the volatile part will get digested or will get reduced. The fixed part will remain as it is. So we generally assume that, but here in this question it is specifically said also. So it is a universal fact in digestion. Okay, so this is what we do. Okay, so we'll see how to solve the problem now. So suppose I am taking for 1 kg of dry untreated sludge. We have 1 kg of dry untreated sludge. So my fixed solids percent, how much will be my fixed solids percent? We know that the percentage is 32. So 0.32 divided by 0.32 plus 0.68, that is 1 into 100, that is 32%. So my fixed solid percentage in the untreated sludge, it is given as 32%. So suppose now let X equals to the weight of volatile solids after digestion. Okay, so suppose we don't know that after digestion what is the weight of my volatile solids. Earlier it was 0.68 which we have considered, but now we don't know after digestion what will be my weight. So again, if we calculate the fixed solids percentage, so this was in untreated sludge. The earlier calculation was in untreated sludge. Now we will find the fixed solid percentage in digested sludge. So in the question, it is given as 50%. It is given as 50%. So again, with the same formula, we can write 32 kg divided by 0.32 plus x, because I don't know. Earlier this was 0.68, now I don't know, into 100. This is x. Okay, is equal to 50%. So in this way I will be able to find out the x, which is 0.32 kg. So before digestion it was 0.68. After digestion my volatile matter is 0.32 kg. Okay, so what will be my weight of digested solids? It will be 0.32 plus 0.32 equal to 0.64 kg. Okay, so my percentage reduction in total solids RTSS will be 1 minus, earlier it was, or it is the weight of the solids. Sorry, it is the weight of the, not the digested solids. It is the weight of the solids after digestion. After digestion. It is 0.32 of fixed solids and 0.32 of digested solids. Okay. So 0.64. So my total solids, earlier it was 1 kg. So from 1 kg, it minus 0.64 divided by 1 into 100, that is 36%. So my,
Sir,
yeah, tell me.
it is a percentage reduction in total suspended solids.
Total solids, total solids, not SS.
That 2S. Okay.
Total solids, total solids. Okay, total solids and percentage reduction in volatile solids. Volatile solids. So RV, I will just write VS is equal to, earlier it was 0.6 set, now it is 0.32 divided by 0.6 set into 100. So it will be equal to 52.9%. So this was what is asked. Okay. So simply just taking it as X, we found out what is the volatile percentage, volatile solids after dilution, and then the percentage reduction in both the case of total solids and volatile solids. Mostly the parameters which are given is volatile suspended solids and volatile total solids only. So that's why I had written suspended double S, but you can write it as total solids also. So as per the question, it is 52.9%. I hope it is clear to everyone. Others, are you able to understand the problem? Kindly respond.
Yes, sir.
Okay, thank you. Okay, so this was the third question. Now we'll move on to the fourth question. Okay, so the total volatile solids reduction is 52.9%. Okay, so this is the last question. It is a simple question, looks a big problem, but it's a very simple problem. So in total, 500 meter cube per day of combined sludge at 2.5 percentage solids and specific gravity of 1.01 are thickened and dewatered. The performance data of the thickener and the dewatering facilities are given below. Determine the volume of processed sludge and the side streams, and then draw the process diagram. I will show how to draw the process diagram. Like, we have to just find, calculate and draw the diagram. So there is a combined sludge which is first going through the thickener. So there will be change in the characteristics, and after, from the thickener it is going to a dewatering facilities. Okay, so we have to find out the characteristics after each of these facilities, after the thickener and after the dewatering facility. Because some part will be getting removed, some part will be coming as a side stream. So we will see how it is changing. So both the thickener characteristics and dewatering facility characteristics are given, like what is the solid capture efficiency, what is the solid content of the thickened sludge, and the specific gravity of the sludge. And same in the case of dewatering again, solids capture efficiency, then the solid content of the sludge cake, and then the specific gravity of the sludge cake.
Sir, what is side streams?
Side stream means, suppose the combined sludge is coming, okay, it is entering the thickener. Then some part will get thickened and some part of water will just come out as it is. Okay, you understand my point? What is the meaning of thickener? It is reducing the water content. It is increasing the solid content and reducing the water content. So the water should come out as side stream, and the sludge will move forward to the dewatering facility again. You understand my point? Okay. We will see. We will understand it better once I solve this problem. Okay, so we'll see how to go about this problem. This is my question number 4. So first we will see, like, what is the dry solids in my raw combined sludge. we have been given the characteristics of the combined sludge. We'll first find out dry solids in raw combined sludge. Okay, so it will be equal to my first flow rate into, we know 2.5 kg of dry solid is present out of 100 kg of wet sludge. So 2.5% means 2.5 divided by 100 into the density. Density is given as density is specific gravity into 1000. Specific gravity is 1.01 into 1000, so 1010 kg per meter cube of wet sludge. This is the total source, so I am writing as a wet sludge. So it will be equal to 12,625 kg per day. So in my combined sludge, there is dry solids of 12,625 kg per day. Okay. So now it is, this raw sludge is now moving into the thickener. So in thickener, the solids will get captured. So what is the capturing efficiency? The capturing efficiency is given as 85%. So we will find out now the dry solids captured by sludge thickener. Okay, so this will be equal to 0.85 into 12,625, which is equal to 10,730 kg per day. So at first my dry solid coming as 12,625. Of From it, 85% is getting captured in the sludge thickener. So my volume of thickened sludge. So now after sludge thickener, the volume of the thickened sludge will change. The volume per day will be around 730 kg per day of dry solids. Again, the same formula, into out of 100 kg of wet sludge, we have 6 kg of dry solids, into 1 by the density kg per meter cube of wet sludge. So earlier we found out the dry solid content. Now we are finding out the volume. So slightly the formula will change. The left hand side, right hand side. So it will be equal to 776 meter cube per day. So this is the volume per day in the thickened sludge. So we know that 500 meter cube per day of flow rate was coming in from the, and in the sludge thickener 176 is getting captured in the thickener. So that my, what would be my side stream? So my side stream, yeah. So my side stream value will be 500 minus 176. That is 324 meter cube per day. Okay. Now again, now after this sludge thickening, it is going to dewatering. So again in dewatering, some part of solids will get captured. So what is the capturing efficiency? It is now 90%. So dry solids captured by sludge dewatering facility, it will be, earlier it was 10,730 into zero point 0.9. Okay, so it will be 9660 kg per day. Now again, we know the dry solids captured. So my volume of sludge cake that is in the dewatering will be equal to 9660 kg per day dry solids into 100 kg of wet sludge divided by what is the solids percentage, 25, 25 kg dry sludge into 1 by 1020, the density given in the question. So it will be around 38 meter cube per day. So again, this was at first we found out the side stream 1. So my side stream 2 from the sludge dewatering will be 176 was coming minus 38, which is 138 meter cube per day. Okay, so now I will draw the flow chart. You will be able to understand this in much better way. I will draw the flow chart. Okay, so let's see now. Suppose this is the raw combined sludge that was coming. So the volume, or you can say the flow rate, that is the volume per day, it is 500 meter cube per day. It was coming. So first we have the sludge thickener. So here the efficiency of capturing is 85%. So the dry solids that was coming into the system was 12625 kg per day. So since 85% is getting
Sir, this color is not right.
this color.
Yes, sir.
Okay, okay, I will change the color. This one is visible, which I am typing now.
Okay, sir.
Okay, then I will just quickly erase everything. Okay, maybe light, only light colors. Yeah. I hope this yellow color is visible. Okay, so suppose this is the raw combined sludge that is coming into the system. Okay, the volume was 500 meter cube per day, and the dry solids content was 12,625 kg per day. Now it is first going into the sludge thickener. So the efficiency of solids capture was 85%. Okay, so now the dry solids that is coming out of this system will be around 10,000 sound because 85% is getting captured, and the volume will reduce. The sludge volume will definitely reduce. It will be 176 meter cube per day, and the difference between the 500 and 176 will come out as side stream, that is 324 meter cube. So you understand what is the side stream and what is the what is the other stream. This is carrying the solids, which is 176, and the other thing is the side stream, which is coming as water. And then again it will go to the dewatering dewatering facility. Here the solid capture is 90%. So my dry solid content will become 9660 kg per day. Okay. And the volume that is coming out is only 38 meter cube per day. So the rest 138 meter cube per day will be coming as side stream. So my total side stream SS will be, or I should not confuse you. So my total side stream will be equal to 462. So my total side stream will be equal to 462 meter cube per day. Okay, is it clear now? Just try to see this problem once again. Is it okay? Shall we move forward? Guys, please respond. Or any part which you didn't understand.
Sir, quick revision.
Sorry,
Quick revision.
quick revision. Okay. See, so you want to know about the schematic of the problem or how to solve the problem? Like the last, you want to know the basic concept, like how it is, what is the schematic? I will tell you. Uh, Suppose this is the raw combined sludge. A sludge is coming into the from somewhere. Okay, the volume is around 500 meter cube per day. The dry solid content which we have found out is to be 12,625. Now it is coming into the sludge thickener. Okay, so in sludge thickener, it will try to segregate the water part and the solids part. So most of the solids part will be getting captured. So the efficiency has been given as 85%. So 85% of the total solids will be separated in the sludge thickener, and the rest 15 percentage with most of the water will come out as side stream. So this is the side stream which will carry the 15% of the solids and the most of the water, whereas the dry solids after 85% capture will be coming out of the sludge thickener. Then the volume, corresponding volume will be 176 meter cube per day. And then after sludge thickening, we will go for dewatering. In dewatering, again, most of the water will be getting separated. So with that amount of water, 10% of the solids will also will get removed. So my side stream volume again will be 138 meter cube, and after capturing 90% of the solids, I will get my uh, total dry solids after dewatering has to be 9660 and the volume to be 38 meter cube per day. So both these things are just separating, we can say separating the solids from the liquids mostly. It will not be 100% efficient, but first one was 85%, the next one was 90%. 90% of what is entering into the system, not the total is 90%. Okay, so to solve the dry solid content, first for the dry solid content of the combined sludge, the flow rate into the solid content 2.5 into the density. We will get the dry solid content of the combined sludge. So if we know the dry solid content of the combined sludge, we can find out what will be after my thickening. That is 85%. So this 85% will be my dry solids after thickening. And what will be my volume of the thickened sludge? We can find out with the help of this flow rate into 100 by 6. That is my solid content in the thickened sludge into 1 by the density. So I found out the volume of my thickened sludge. So if 176 is the volume of my thickened sludge, my side stream will be 500 minus 176. So that is 324. So like this we solve. Same again we have to find out for the sludge dewatering facility. What is the dry solids, then the volume of the sludge cake, and then the side stream. It is very easy, just we have to play with the values. Anything else? If you can visualize the problem, then the problem is solved. Shall I move forward? Or tell me which part is not clear to you? Others, you have any query?
Sir, in this diagram, there are two side streams, right?
Yes, yes.
Okay.
With two side stream because there are two different systems. First, there is a sludge thickener. Okay,
Yes.
so from such thickener, one side stream will come, one water will come, and from then dewatering, again one side stream will come.
Yes.
So since there are two operations, one after another, there will be two side streams. So this side stream is nothing but basically water with some part of solids. Whatever the solids that system is not able to remove will come out as the side stream.
Means it is like a effluent.
You can say, yeah, but in this system we will say the effluent as the dry solids. So
Yes, sir.
yeah, but you can say, yeah, this is another effluent. So two effluents are coming. One is with more solids, one is with less solids.
Okay, sir. Okay.
Okay. Okay, we will see the some of the MCQ problems because we have discussed the numerical problems in detail. So in sludge treatment, not much type of numericals are available. Only these are the numericals which are mostly asked. Okay, so quickly we will go through the multiple choice questions. Which of the following is not a major component of primary sludge? Organic sediments, dissolved organics, suspended organic matter, biomass produced at the biological treatment stage. So which of the following is not a major component of primary sludge? In primary sludge, what you won't have majorly? Any guesses? You can guess, we can discuss.
Inorganic sediments, maybe, sir.
The inorganic sediments, do you think it is not a part of primary sludge, or it is the major part of primary sludge?
So biomass produced at the biological treatment stage.
Yes, that can be. Okay, we will see what is the answer. So basically, the answer given here is dissolved organics because dissolved organic will definitely will not a part of primary sludge. Biomass produced in the biological treatment system will also should also be the answer. I don't know why they have not taken it is the as the answer, but I think biomass will also should not be there. But maybe some part. of biodegradable or biodegradable matter which is produced in the system from the earlier portion is considered. The major idea behind this question is in the primary sludge, most of the settleable part will get removed. Okay, which are easily settleable. Dissolved organics cannot be settled. Okay, so dissolved organic is the major component. So if you see the major component which is not a part of primary sludge, it is the dissolved organics. There can be some biomass can be there, or there can be some suspended organic matter which can be settled. So it can be a part of primary sludge, maybe, we but inorganics will definitely be a part of primary sludge. Okay. So here, if you are asking about the major component which is not a part of the primary sludge, then it would be dissolved organics only because it cannot be settled in that much time. Okay. Saket, you are saying something?
Okay.
Ah, okay. Kirti, is it clear to you? Because inorganics is the part of primary sludge. So A cannot be the answer. Okay.
Yes, sir. Yes, sir.
Okay. So now match the type. So we have waste activated sludge, sand and heavy solids, oil and fats. And we have some systems, grit removal system, secondary clarifier and skimming tanks. So we have to match. It is a direct question.
Option A.
Option A, waste activated sludge. Yeah, I think option A is correct. Yes, option A is correct. Because the waste activated sludge will be removed in the secondary clarifier. The sand and the heavy solids that are the suspended inorganic particles will be removed with the grit chamber, and then the oil and fats will be skimmed off in the skimming tank. Okay, so this is the answer. The next question: the sludge component that does not directly reach the sludge processing unit. So the sludge component that does not directly reach the sludge processing unit is return activated sludge, waste activated sludge, primary sludge, none of the above. Which of the component does not go reach directly into the sludge processing unit? So in so if you remember in sludge
Sir,
process, yes.
return activated sludge.
Okay, so where do you think the return activated sludge is sent to?
Sir, because return activated sludge is uh, is going to first means where influent is coming.
Where? Can you tell me the tank name or which part?
Sir,
You are right,
aeration
but
tank. Aeration
aeration
tank.
tank. Yeah. So return activated sludge is basically sent back as as an inoculum or as for biomass. So for biomass to maintain the biomass content in the aeration tank, we send a part of the sludge into the aeration tank. So it is going there, whereas the waste activated sludge and the primary sludge will go to the secondary will go to the sludge processing unit. Okay, I hope everyone understood that. Next question. The volume reduction of sludge is typically achieved through. So in the for volume reduction of sludge, we reduce the inorganic solids, we reduce the water content, we reduce the biomass, or we reduce the organic matter. So for volume reduction of the sludge, which is the major component? So first tell me, like sludge is made up of what materials? One is water and one is the organic matter. So how much water is present?
Water content.
What is the water content in sludge? Percentage.
Sir, water content is a major part of sludge.
Yes, it is around 99 to 95%. Okay, 99, yeah, 99 to 95%. So major is the water content. So if you reduce the water content from the sludge, then the volume reduction will be much higher than the other solids. So B is the correct answer. Next, which of the following is not an objective in sludge thickening? So in sludge thickening, which of these is not an objective? Reducing the total volume of sludge, increasing the solid content, reducing the water content, increasing the organic to inorganic matter ratio. So which is not an objective?
Increasing the organic to inorganic matter ratio.
Yes,
Yes.
exactly. Because we are not concerned about the organic to inorganic matter ratio. No, we try to reduce the volume, we try to increase the solid content, and we try to reduce again the water content, which in turn reduces the volume. So D is the correct answer. Next question. Sludge conditioning can be obtained through iron salt addition, lime salt addition, hydrolysis, any of the above.
The iron salt addition and lime salt addition.
Anything else?
Sir, I think option D will be correct.
Yes, so any of the above is the right answer because hydrolysis will also help to remove the water gel pack, the what break the water gel pad and condition for sludge dewatering. So hydrolysis will also be an option rather than the iron salt or the lime salt addition. Okay, so all the three are correct option. So option D is correct. Okay, so the next question is you have two statements. The first statement says the ratio of volatile to total solids indicate the organic fraction of the sludge. The density of specific sludge sample is typically highest in the raw form. So it is telling that for a sludge, the density is highest in the raw form and it reduces with the sludge processing stages. So you have to tell me which of the statements are true or both are true. Explanation of one another. Okay, we will discuss. So the first question, first statement says that the volatile to solid total solids ratio will give the organic fraction. That is true,
Sir,
right? Tell me.
so density will be
Hmm.
increased
Yes,
with sludge processing stages.
yes, definitely.
But
So
here is but
it
okay,
is
sir.
given as decreasing. So statement B
Yes,
is
sir.
false because with each processing stage, we increase the solid content. So if the solid content is increasing, the density will definitely increase with each of the process. So statement B is false, A is true. Okay, A is true because it is directly given volatile to total ratio will give the organic fraction mostly. So this is the rough way to calculate it. And so option C is correct, A is true, B is false. Okay, the next question. Filling the blanks with appropriate stage. So thickening, stabilization, dash, ionization, drying. So fill up the blanks.
Dewatering.
Dewatering, yeah, it is pretty direct. Dewatering is the right answer for this. So as per the first, we will go for thickening, then stabilization, then we will dewater the sludge, do the hygienization, and then the drying. So this is the main sequence that is followed for sludge processing. Okay. Next question. Centrifuge, filter press, and belt press are different types of dewatering system, conditioning system, hygienizing system, digestion system. So, what are these systems? Pretty simple if you know all the systems. So, just see the name filter press, belt press. If we do these things, what will happen to the sludge? It will help in what? Will it digest the sludge? Conditioning. Is it for conditioning? Do we use filter press or belt press?
No, sir, conditioning is not correct.
So it cannot be conditioned. Digesting means we do anaerobic or aerobic digestion. Okay, hygienization means removing the pathogens. So what is removing? What is remaining? Dewatering, right? Because if we are belt pressing it, if we are filter pressing it, what is happening? Water is coming out, so it is dewatering the systems, right? It is centrifuging. Water is separated from the solids. So all these are dewatering systems. Okay. So these are all mechanical sludge dewatering systems. Next question. Which of the following offers an option to use sludge for energy production? Land disposal, aerobic composting, anaerobic digestion. Both A and C. So for energy production, which of the following case can be taken? So we generate energy in terms of which gas, can you tell me? Majorly which gas gives us the energy?
Sir, land disposal.
Land disposal. So if you are disposing the sludge in land, will it generate energy?
Sir, methane will be produced
Okay.
in
But
an anaerobic condition.
anaerobic condition, right? So anaerobic digestion is the correct answer. Okay. If you simply do land disposal, yes, there will be some part which will be getting degraded. It may or may not produce methane. It is open to air. Maybe it is not getting the anaerobic conditions as such. Maybe after putting so much of waste, the waste in the lowest part will be getting some anaerobic condition and it will be forming methane. But we don't have any systems attached in the land disposal area to take out the methane, right? So anaerobic digestion is the most logical and correct answer. Okay, because in anaerobic digestion we have a mechanism where we capture all the methane that is coming out from the system and then we produce energy from it. So though land disposal can also create some methane, produce some methane, but that is not the right way or correct way. We cannot control anything in that matter. Okay, so that is not the correct option for energy
Sir,
production. Yeah.
sir, we can do anaerobic digestion with landfill or any other process.
Yes, we can, but the in land disposal, we are it is not meant for energy capture, right? It is just simply disposing in the land. So most of the waste will be uh, exposed to open air, okay, or aerobic conditions. Only the waste which is lying inside the heaps of waste will be in anaerobic condition, and from them some part of methane maybe will be coming out, may or may not be coming out. Okay, and we don't have any system to capture that methane also for energy production. So land disposal is not a scientific or correct way to produce energy. We cannot control anything in that matter. But in the case of anaerobic digestion, we can control everything. We can control how much methane is getting produced, how to purify it, and how to use it for uh, energy production. Is it clear?
Sir, we will make a separate plant for anaerobic digestion of.
Yeah,
Uh,
see, if you are making a separate plant, that means you are doing anaerobic digestion properly, right? So it becomes anaerobic digestion. It is not land disposal anymore. You can take the things from the land disposal, put it in anaerobic digestion, and then capture the energy. We are not directly capturing the methane from the land disposed things, right?
okay, sir.
Okay. So the next sludge hygienization is primarily is a process of. So in sludge hygienization, what do we do? Reduce the weight and volume of sludge, dewater the sludge, reduce the content of pathogenic bacteria, and all of the above. So which of the following option is correct for sludge hygienization?
Pathogenic bacteria content.
Yeah, it is reducing the pathogenic bacteria. Okay. And this is the last problem. An apparent disadvantage of using sludge drying bed for dewatering is. So what is the disadvantage of sludge drying bed? A, it's a complicated process, more applicable for industrial sludge, high energy requirement or high land requirement. So what is a disadvantage of sludge drying bed? Is it a complicated thing? Just think about it. We're talking about sludge drying beds. Okay.
Large land requirement.
Large drying beds simply. So if we have to dry anything, we have to provide a huge area for it for drying. Okay, because so much of waste is getting or so much of sludge is getting generated every day from any wastewater treatment systems, so it requires a huge land area. And although it's a very simple process and there is no energy requirement, so everything else is okay, only the only disadvantage is large land area. Okay, so this was these are all the questions which I had. We have solved the numerical problems earlier, and then we have seen some multiple objective type questions. So this was all I had for practicing to help you solve the assignment questions this week. So if you have any doubts about which we discussed today, you can ask me right now, or you can send me a mail in my mail ID shaha19akash@gmail.com. And we will have the next session again on 26 September, same time, 7 p.m. And if you have,
Sir,
yeah, tell me.
sir, in this day, it's Tuesday.
Okay.
Sir, there are two live sessions. One is 6 to 8,
Yes,
and
yes,
second is 7 to 9.
yes, yes, yes.
So what we have to do?
No, see, there is, this is for your suitability only because if you are free from 6 to 8, you can also join the other session also. Uh, More or less, I don't know what type of questions are solved in that session. It is related to the week's content only, but we prepare our own materials. So maybe you can also try that session, learn something, and then come back for the 7 p.m. class. Okay. So the questions related to particular weeks will be discussed in the sessions. So as per your suitability, you can join any of the courses, any of the sessions.
I like your sessions.
Okay, thank you. Okay, so if you don't have anything else to discuss, you can leave the session, or else you can always write to me in my mail ID. Okay, and this video will be uploaded by tonight, I think. You will maybe if you subscribe to my channel, you will get a reminder about those. I will put the name of my channel, YouTube channel, where I upload these videos. It is Akash Shah NPTEL. So if you search this channel in YouTube, you will get all access to all the videos and all the week's content which we are discussing. But it's always better to attend the live classes so that you can clear your doubts then and there. So each day, in each class, we will first solve some numerical problems and then we will discuss the MCQ problems. Okay.
Sorry, sir.
Yeah, tell me.
Yeah, I came late, but I noticed something, so I need to ask on the question 4.
On the question
The use
4,
of 100. Yeah, the use of 100. Are you taking it as the whole thing? That's a meaning it's a percentage, but you're taking it as a whole thing, which means it's 100 of the whole thing
in the question 4 of subjective type
in
or
the
calculation?
calculations part.
In question 4 or in question 3? In this question, right? Yeah, I think you're talking about this question. Yeah, so in this question, question number 3, we first assume that there is 1 kg of untreated sludge. Okay, we first consider that there is 1 kg of untreated sludge. In that, the first fixed solid percentage is 32%. It is given in the question. Okay, so out of 1 kg, 0.32 is my fixed sludge and 0.66 is my volatile sludge. Then after digestion, we don't know how much volume is being digested. And we know that digestion will only happen to the volatile matter, not the fixed matter. The fixed matter will remain same. I think he has left the chat. Yeah, Winston? Yeah, are you able to hear me?
Yeah, I had some network problems. I can hear you.
Yeah, so as I was saying, we have 1 kg of untreated sludge. Okay, so in that 1
It was
kg,
the fourth questions.
it was
Fourth
fourth
question.
question. Okay, fourth question.
Fourth.
Oh, okay, 100. This
Yes.
100. Okay,
Yeah.
okay. I will tell you. Wait. In the fourth question, see, in the fourth question, it is saying that in the first line it is saying as 2.5% of solids. So out of my total flow that is coming into the system, 2.5% is my solid. So how to write the percentage? 2.5 by 100. So it means that out of 100 kg of sludge, 2.5 is my sludge, is my solid. So that's why I'm writing just 2.5 by 100. Okay. Is
Okay.
it clear now?
On the
Yeah,
clear. On the can you show the question, the
yeah,
calculation part?
yeah.
Okay, the 100 in this volume of thickened, which is
Okay. So in so
10,700. The 100 which I'm talking about, it's the upper one. In this part of 10,730 times
okay,
100
okay,
kg.
okay. Now here, see, in the first
Yeah.
part we are finding the dry solids. Okay, but here now we have to find out the volume. So if you are finding the volume, my left hand side will come to the right hand side and everything will get reversed, right? So now it is 6 by 100 instead of, sorry, it is 100 by 6 instead of 6 by 100, 6 being my percentage of solid content. See, in the thickener there is 6% of solids, so I have to write 6 by 100. But since I am finding the volume, so volume part will remain in the LHS, other part will shift to the right hand side, so it will become 100 by 6. So I am writing in terms of percentage. Okay.
Okay. Okay, I
Okay.
got it. There I
Yeah, yeah.
understood.
Okay. So in the
Thanks.
first part, I was calculating the dry solid content. Next, I am calculating the volume. So if you see, so that's why the equation is changing a little bit. Okay. The equation is changing a little bit. That's why again in the density parameter, it is getting 1 by 1015. Earlier it was 1010 in the numerator part. Now it is coming in the denominator part because now I am finding the volume. So just it will get reversed. That's all. Nothing else. Okay. Okay. So I hope other things are clear. If you have any doubt, you can ask me later also. So if you if you all are okay, I will close the session now. Is it fine, or do you have any other queries? Wisdom?
Nothing, nothing.
Okay, then you can leave the session.
I'll go, I'll go through. I'll
Yeah,
go through the
sure, sure.
sense.
You
Yeah.
can go through and you can write to me in my mail.
Yes.
Email ID.
Yes.
Okay.
Okay.
Others
Thanks.
can also leave the session, please, so that Chinmay, Jay, Satvik, do you have anything to ask?